alaikum. Hope all of you are fine. This is Saleem. So today we are going to discuss about matrices operation, that is addition, subtraction, multiplication, and divisions. And also we'll look at some of the properties, that is additive inverse and multiplicative inverse. So today we will discuss about first addition. Let's get started. So first addition. So let us consider two matrices, that is A equal to 1, 2, 3, and 4, and another matrix B which is equal to 4, 5, 6, and 7. So if you want to add two matrices or you want to subtract two matrices, then you have to look at the order of the matrices. If the order of the matrices are same, then the matrices are conformable for addition, otherwise they cannot be added or subtracted. So you have to check order. First, order of the matrix A is 2 by 2. There are two rows and two columns, and the order of the matrix B is also 2 by 2. So you can add these two matrices. So what is A plus B? So this is 1. This is 1, 2, 3, and 4. And you want to add this matrix in matrix B, which is 4, 5, 6, and 7. So if you want to add these matrices, then you can add it like 1 plus 4, 2 plus 5, 3 plus 6, and 4 plus 7. So this is term by term addition, element by element addition. So also if you want to subtract, then you can do this like that. So this is 1 minus 4, 2 minus 5, 3 minus 6, and 4 minus 7. Or if you want to add, this is 1 plus 4, 2 plus 5, 3 plus 6, and 4 plus 7. So the answer for the addition is 5, 7, 9, and 11. And answer for subtraction, if you want to subtract, then your answer should be equal to 1 minus 4, that is minus 3, and 2 minus 5, which is also minus 3. 3 minus 6 is also minus 3, and 4 minus 7 is also minus 3. So this is the answer for subtraction, and this is the answer for addition. So addition and subtraction is quite simple, but multiplication is a little bit difficult for the students. So let's get started. Multiplication. So what is multiplication? If you want to multiply matrix A, let's suppose matrix A is 1, 2, 3, and 4, and matrix B is 3 and 6. Now if you want to multiply this matrix A by B, now if you want to multiply matrix A and B, then you have to check first the rule for multiplication. So what is the rule? So rule is columns of A should be equal to rows of B. If matrices follow these rules, then they are conformal for multiplication, otherwise multiplication will not be possible. So let us look at the order of the matrix A. This is 2 by 2. and this is 2 by 1. So column of A is 2 and rows of B is also 2. So we can multiply these two matrices. Now, how you will multiply these matrices? 1, 2, 3, 4, and this is matrix 3 and 6. So if you want to multiply, you have to follow first row, first column, which is 1 or 2. In order to explain you, I have to do some rough work. This is first row. 1 and 2 is a first row. And this is the first column. Here is only one column. So I have taken a simple example for multiplication so that you can understand. Now multiply 1 by 3, which is 3, and 2 by 6, which is 12, and you add these two values. So this is 15. So what you have to do? You have to multiply first row, that is 1 multiplied by 3, that is 1 multiplied by 3 plus 2 multiplied by 6, and second row, what is second row? This is 3 and 4, and first column, that is that is 3 and 6. So if you multiply 3 by 3, which is equal to 9, so here comes 3 multiplied by 3 plus, and this 4 is multiplied by 6, so 4 multiplied by 6. So you have 3 plus 12, and this is 9 plus 24. So you have 15 by 33. So this is the required answer for multiplication. Now, how can you know the order of the matrix AB without multiplication? So let's check. Order of the matrix A is 2 by 2, and the order of the matrix B is 2 by 1. So if you want to multiply A by B, then this should be equal. So this is the rule. This should be equal, and take columns, take rows of A, which is 2, and columns of B. So this is 2 by 1. So if you want to find the order of the matrix AB without multiplication, you can find through the orders of the A and B. So the order of the matrix AB should be equal to 2 by 1, which is 2 by 1. So we have two rows. This is AB. This is AB. Here are two rows and one column. So this is 2 by 1 matrix. So now what you have to do, just skip the columns of A and rows of B. Then the order matrix will be rows of A and columns of B. Order of the resulting matrix basically. So now let's move on to the other example. I will take a 3 by 3 matrix here. So now this is 1, 2, 3, 4, 5, 6, 7, 0, 1. And I want to multiply it by 2, 0, 0, 1, 1, 0. So if you look at the order of the matrix A, order of A is 3 by 3, and order of B is 3 by 2. So the columns of A is equal to rows of B. So this multiplication is possible. Now what you have to do, if you want to find the order of the matrix AB, then this should be the order of the matrix AB. So our answer should come a 3 by 2 by 2, 3 by 2 matrix. So now let's multiply and check whether it comes or not. So 1, 2, 3, 4, 5, 6, 7, 0, 1. This is 2, 0, 0, 1 and 1, 0. So now if you multiply first row, first column, this is first row, this is our first row, and this is our first column. So we are multiplying this row by this column. So 1 multiplied by 2 plus 2 multiplied by 0 plus 3 multiplied by 1. So now again first row and second column. This is first row and second column. So first row, second column should come here. So 1 multiplied by 0 plus 2 multiplied by 1 plus 3 multiplied by 0. So now let's move on to the second row. So if you want to multiply second row, this is second row. This is second row. Now multiply second row by first column. So 4 multiplied by 2 plus 5 multiplied by 0 plus 6 multiplied by 1. So now if you multiply 4 multiply 0, first row, sorry, second row, second column. Second row, second column should come here. So this is 4 multiplied by 0, 5 multiplied by 1, and 6 multiplied by 0. And last third row multiply by first column. So 7 multiplied by 2, 0 multiplied by 0, and plus 1 multiplied by 1. So now third row and second column. So third row, second column, 7 multiplied by 0 plus this 0 is multiplied by 1 and 1 multiplied by 0. So what is the answer? So this is 2 plus 0 plus 3. And this is 0 plus 2 plus 0. And this is 8 plus 0 plus 6. And this is 14 plus 0 plus 1. And this is 0. This is 0 plus 5 on the 5. And last is 0. So this is 0 plus 0 plus 0. because 7 multiplied 0 is 0, 0 multiplied 1 is 0, and 1 multiplied 1 multiplied 0 is 0. So what is the required answer? So the required answer is, this is 5, 8 plus 6, 14, and this is 15, and this is 2, this is 5, and this is 0. So you have a matrix which is AB, and what is the order of the matrix AB is, it is 3 by 2. So if you check it here, this is 3 by 2 matrix, and you have already calculated your answer should be a 3 by 2 matrix. So it is confirmed. Now let's move on to the some of the main definitions. That is, what is additive inverse and multiplicative inverse. So we have already defined some of the properties. That is, identity matrix we have already defined, null matrix we have already defined. So what is additive inverse? So if you have a matrix A and you want to add a matrix in A such that your answer is a null matrix, then you have minus A. So A and minus A are additive inverse of each other. So because this is the additive identity of the matrices. A and A inverse, A and minus A are the additive inverse. For example, let's suppose A is a matrix 1, 2, 3, and 4, and B is a matrix. Sorry, B is a matrix. Let's suppose minus 1, minus 2, minus 3, and minus 4. Then if you add A and B, you have a null matrix, because 1 minus 1 is 0, 2 minus 2 is 0, 3 minus 3 is 0, and 4 minus 4 is 0. So this is the O2 matrix, that is a null matrix of 2 by 2, 0, 0, and 0. So these two matrices are additive inverse of each other. So if you have a matrix A, let's suppose this is a matrix 1, 2, and 1 and 2. So minus A, that is minus 1 and minus 2, is the additive inverse of A. So now we will define multiplicative inverse similarly. So if you have a matrix A and you are multiplying it by a matrix B such that your answer is an identity matrix, then A and B are said to be the multiplicative inverse, because we are multiplying. This is the same as if you have seen 2 multiplied by 1 upon 2 is equal to 1. So 2 and 1 upon 2 are the multiplicative inverse. 3 and 1 upon 3 is a multiplicative inverse. So you have a multiplicative identity here. This is a multiplicative identity with respect to multiplication, that is for real numbers. Now we have a matrix which has a real number, but this is a matrix. So you have to define a matrix which is an identity matrix. So if you multiply A and B, then your answer should be equal to I, and the order of the matrices should be same. So if you have a matrix A and you want to multiply it by a matrix, and we represent the matrix B here like is A inverse, which is equal to 5. So what is I? This is, for example, this is I2 1001, and this is I3 100 010 001. There are several methods to calculate A inverse, that is multiplicative inverse, but we are not going in detail in this lecture. We will inshallah follow this uh, methods, hopefully. So you will be able to understand how we calculate adjoint of a matrix of 2 by 2 matrix and 3 by 3 matrix and determinant. So, but let's make it simple today. Now, let's move on to the other properties. I have already defined commutative property here. So, what is commutative property? If you multiply, if you add A and B, then B, A plus B should be equal to B plus A. This is a commutative property for addition, or with respect to addition. Now, if you multiply A multiply by B and B multiply by A, this may not be the same. In general, they are not equal. So this is a commutative property. Commutative property that does not hold for the matrices. In general, there are some matrices that follow this property, but most of the matrices does not follow this property. That's why they form a non-abelian group. We will talk about the groups later, inshallah. So, what is associative property? So, if you add A plus B and C, then this is equal to A plus B plus C. Sorry. So these are the properties which we will use in our questions, and inshallah in the next lecture we are going to start exercise 4.1, some of the important questions, and thank you. Allah Hafiz.